Hello friends, welcome again to this channel. Today we have a circuit problem in which a resistor is in series with a capacitor, and we are to determine the frequency of the power supply and also the angle between the current and the voltage. So let's go. Reading the problem, it states here that a series circuit consisting of a 40 ohm resistor and a 100 microfarad capacitor has an effective current of 12 ampere passing through it. Determine the frequency of the power supply if the effective voltage is 600 volts. By what angle does the current leads the voltage? Now let us illustrate the problem. So the problem has a resistor and a capacitor in series, and the value of this resistor is 40 ohms and the capacitor is 100 microfarad, and the current also flows through this element. The value of the current is given, which is 12 ampere. We call it as an effective current. And if a supply was delivered to the circuit, an effective voltage of 600 volts, so we are now to solve for the frequency of the power supply. So what is the frequency of the power supply? So we are looking for the frequency. Okay, so what is the frequency? Now we know that this one is an impedance. Okay, so to be able for us to get the impedance in rectangular form, it is generally represented as ZR plus JXC. Since this is capacitor, so we use the notation X sub C. But we can also get the impedance by this one. Z squared is equals to R squared plus XA squared. Okay, we use the right triangle in which this is your Z and this is your R and this is X sub C. So to be able to solve this, we apply the Pythagorean theorem. Now the R is given here, which is 40 ohms, and also the part where the capacitor in this capacitive reactance. And we can also solve for Z here. The value of Z is simply as using the Ohm's law. Okay, by Ohm's law, which is B is equals to IR. So the current, but instead of using R, I use the impedance. So we can right away solve for Z. So that will be V over I. So since that there is the effective voltage, which is 600 volts, and also the effective current, which is 12. So automatically we have 600 divided by 12, which gives us 50. So the impedance value is 50 ohms, and 50 ohms now can be used in this formula. So we just substitute. So we just simply write 50 ohms squared is equals to R. R is here. This is R. Okay. So R is 40 ohms squared plus X sub C. X sub C. But X sub C is actually 1 over omega C. This is the capacitive reactance, where your omega is 2 pi F. Okay? So therefore, we are going to substitute it here. By the way, we just get now the value of 50 squared. So you have here 50 squared minus, we place it on the left side, the 40 squared equals, by the way, this is squared, okay, see, X sub C squared. So you just have the square of that minus 40 squared also, and it will give us 900. So this is 900 equals X sub C squared. Therefore, your X sub C is the square root of 900, and the square root of 900 is 30. Okay, so we get now X sub C. So we substitute it here. So that will be X sub C using this one. So X sub C is 30 is equals to 1 omega C, and omega is 2 pi F. So that is 2 pi F C. Okay, so therefore this is equivalent to 2 pi F, and C is given also, the value of C here, this is C. So that is 100 microfarad, and I'll change it to farad, so that will be times 10 to the negative 6 farad. Okay, so this will now be the equation. So you now can solve for F, and the value of F is this one. So you have 30 times 2 times pi. Okay, you place F on the left side, and from denominator it becomes a numerator, and then 100 times 10 to the negative 6. Okay, so frequency. Now you use your calculator, you multiply the denominator. So that is 30 times 2 times pi times that is 100 times raised to the negative 6. Okay, so that is the value of the denominator, and I get the inverse of this, and it will give me 53.05. So this will be your frequency. This is cycle per second. Okay, so this will be your F. Okay, as an answer. Now the other thing that the problem is asking us is the angle. The angle between the current and the voltage. Since this is a capacitor, therefore it is leading. Okay. It's leading. Okay. So how do we get the angle? So simple. We just use the idea that we are using this right triangle, that our XC is in this side, and this is our R, and this is our Z. So the angle that we are looking for is this one, that is theta. So, but since our XC, X sub C, can be computed already. Actually, it was computed and it gives us 30. The value of XC is 30 ohms, and R is 40 ohms. Okay. So therefore, by taking the tangent, we can solve for theta. So the inverse tangent of the opposite over the adjacent, because tangent is opposite over the adjacent. So the inverse of that is the angle. So that will be 30 divided by 40. So theta, the value of theta, so you divide 30 by 40 equals 0.75, and we get the inverse tangent of this, and it will give us 36.87 degree. Okay, so this will be the angle between the current and the voltage, and this is leading because this is a capacitor. Okay, so it's so simple, and that's it. Thank you so much for watching.